Hi everyone, thanks for watching. In this video, I'm going to show you how to write formulas for ionic compounds when you're given the name. We're still going to leave out transition metals and save that for a later video. Remember that the last video explained how to take a formula like Al2S3 and turn it into the proper name. So we could name the cation as aluminum, name the anion as sulfur, but change that ending to IDE, getting aluminum sulfide. This video is going to pretty much do the same thing, just in the opposite direction. What about if instead you were given the name first and had to figure out what the formula is? We should mention that we've already covered one way to do this in some earlier videos that explained how to draw a model for ionic bond formation. One of the results of that was the formula MgF2 because of the two fluorides. The only problem with this is it takes a really long time. If all you needed was the formula, isn't there a faster way? So to go over this faster way, let's start with a fresh example, calcium fluoride. That's a name. From this, we're going to try to write the formula. The easy part is just write the symbols, metal first, non-metal second, Ca and F. The hard part is filling out those little numbers you keep seeing after each symbol. Should it be CaF2, Ca2F, maybe a 3 and a 2? The point is, how are you supposed to know? Those little numbers, by the way, are called subscripts, and they have to be included for a formula to be considered complete. Their job is simple though, they just are there to indicate how many of each ion is needed. So if I need 3 calciums, I put a 3 there. If I need 2 fluorides, I put a 2 there. The big question then for writing a proper formula is, how are you supposed to tell how many of each ion is needed? To accomplish this, we just have one simple goal. We have to make sure that the net charge, that means the overall charge of the entire substance, is 0. That means it's neutral, not positive and not negative. If I know that my calcium has a +2 and my fluoride has a -1, because those numbers are different, they don't cancel out. They do not add up to 0. So what I have to do is add additional ions. That means more calciums or more fluorides until the two charges actually add up to 0 and cancel each other out. Here's a helpful way to visualize what I mean by a neutral overall charge. Imagine a scale. Everybody knows that a perfectly balanced scale means that whatever mass is on one side, there's an equal mass on the other side to balance it out. But when you're writing a formula, you're really just doing the same thing, but not with mass, just with charge. Whatever positive charge is on one side, there has to be an equal and opposite charge on the other to perfectly balance it out. To hopefully make this super obvious, beneath each side, I'm going to list the total charge, and we'll just go through a couple scenarios. As the scale is listed right now with 1 calcium and 1 fluoride, my total positive is +2, my total negative is -1. Those definitely don't balance out. 2 does not balance out with a 1, or think about it this way, they definitely don't add up to 0. So let's try a different scenario. What if there were instead 2 calciums? That would make my formula Ca2, because there's 2 of them, F, because there's just 1 fluoride. Now my total positive charge is +4. My total negative is still -1. That's actually further away from being balanced. It was 2 and 1, now it's 4 and 1. It doesn't really make any sense. Or think about it in terms of totals. Now my total is a +3. That's further away from 0. This is not going to work. Adding more calciums is not going to help these two sides balance. Or that's a bad formula to suggest. So let's try one more scenario, and hopefully everybody sees where this is going to go. What about if we went back to 1 calcium, but instead added 2 fluorides? Now my total positive is back to +2, but because I have 2 ions that are each -1, they add up to -2. Clearly those two sides balance, they're both the same number. That's what we're going for. If you like the idea of total charge, they both add up to 0. That makes Ca1F2 the correct formula. Before we leave this example, let's just emphasize one more time, all you're doing when you write a formula is adding additional ions until the charges add up to 0 and cancel out. So now that I know my formula is Ca1F2, there's just 2 final corrections we're going to make. Charges and subscripts of 1 aren't typically shown, so even though you may write them to help work through the process, the final version of your formula shouldn't have either of those things written down. Meaning my final formula for calcium fluoride is just CaF2. That concludes this video. Thanks for watching. Here's a brief summary.